Yes friends, so we are continuing with question number 5 now. After question number 4 completed. Okay, I just wrongly told you that question number 3 is completed, but it was question number 4, I'm sorry. Up to question number 4 we have completed. Okay, now let me continue from question number 5. So what was the answer of question number 4? It was 1.3. Why? Because it was 10C1 upon 30C1, right? Because 10 black balls are there. Out of that, one ball is selected, and if it is black, then what is the probability of that? It was from a bag containing 10 black in question number 4, which we just did, okay, which I have just done. So from a bag containing 10 black and 20 white balls, a ball is drawn at random. What is the probability that it is black? That is the question. So for one black ball, because 10 black balls are there, so what are the favorable cases? Favorable cases are 10C1. One ball is selected out of 10 black balls. And total balls are 10 plus 20, 30. So out of 30 in the denominator, we are selecting one ball. So total number of cases are out of 30, 30C1. Okay, so this is upon 30, because 30 into factorial 29 upon 29, we can cancel out 29 factorial. 30 was in the denominator, and in the numerator it was 10 into factorial 9 upon factorial 9. Why? Because difference of 10 and 1 is 9, and 1 factorial is 1 in the numerator and denominator both. 1 factorial is 1. Okay, so 9 factorial cancel out, 29 factorial 29 in the denominator cancel out, only 10 upon 30. 10 upon 30 means 1 upon 3. 1.3 was the answer of picking up a black ball out of 10 black balls and 20 white balls. Okay, one ball was done. So that was the answer of question number 4, 1.3. But let me talk about question number 5. I'm talking about question number 5. What is given to us? Let me first read it and then solve it. A dice is thrown. A dice is thrown. Undoubtedly, it has 6 outcomes. 1, 2, 6. 1, 2, 3, 6 numbers are there in a dice or a die. Here dice is used. This is not to be confused, because die is a singular word which is mostly not used nowadays. Only dice is used as singular or whatever. So a dice is thrown, but it is a die is thrown. No problem, because most of the questions are asked like this. One dice is thrown like that, but actually die is singular number and dice is plural. Now come to a dice is thrown. What is the probability that the number thrown on the dice is, first there are how many options for this? 5, 6, 7 and 8 options are there. My goodness. Okay, so 8 parts of this question are there. Let me do them one by one. So what is the question given to us? We are given here a dice is thrown. A dice is thrown. Okay, now we have to find out. To find here, there are 8 cases here. First is a die is thrown. Then what is the probability? The probability that the number shown. What is the probability? What is the probability that number shown or in the outcome of the dice. Okay, in the outcome of the dice which is thrown, number shown on the dice. Okay, that number shown on the dice shows what shows. Okay, or number shown on the dice each. Now there are different parts of this. Let me take first part. Put the first part here. An even number. What is an even number? It will show an even number. What is the probability of that? Second part is an odd number. Okay, an odd number. Let me write this. Then third part is a number divided by 2. A number divisible by 2. Now number of options are there. Let me write first all the options and then I will do, okay, one by one. So a number divided by 2 we have taken. Fourth is a number divided by 3. A number divisible by 3 is the fourth one. What is the fifth one? Fifth, sixth, seventh, eighth part of here. Then it says fifth. Okay, fifth says a number less than 4. That is a number less than. Let me write less than 4. Right, less than 4. So we can write less than 4 like this. Now this is sixth part. What is the sixth part? A number less than or equal to 4. A number, let me write less or equal to 4. A number less or equal to 4. Let me write symbolically so that it can cover a smaller portion, right? So then seventh part says a number greater than 6. Then it says number greater than 6. What the probability of that we have to find out. Then the eighth part says a number less or equal to less or equal to 6. Less or equal to, let me write 6. A number less or equal to 6. Got the point? Less or equal to 6. All these 8 parts are there. So let me find the solution. Now, what is the probability? That according to the definition of probability of an event is equal to number of favorable cases divided by total number of cases or total number of equally likely cases. In this case, all the cases are equally likely because one dice is thrown or one die is thrown in which six outcomes are there. 1, 2, 3, 4, 5 to 6. There is no 7, nothing. No greater than 6 value. Okay, no greater than 6 number. This is only there are only 6 numbers. Let me first write the sample space. Here, sample space. Let me first write the sample space. After that, we will select them. What are the points? Sample space is 1, 2, 3, 4, 5, and 6. These are the 6 numbers in case of a die is thrown or a dice is thrown. No problem. Then, so here, what is the problem here? First part is with an even number. What are the even numbers? 2, 4, and 6. There are 3 even numbers. So in the first case, let me write number of favorable cases. Number of favorable cases is equal to 2, 4, and 6. This is in part 1. An even number, so not even number. So how many numbers are there? Number of these events or these outcomes is equal to 3. And total number of cases is equal to 6. 1 to 6. That is equal to 6. Or let me take 6 here. Therefore, probability of an even number. Probability of even number is equal to number of favorable cases 3 upon total number of cases 6. So this is 1 upon 2. Try to understand this question. Simple. Number of favorable cases is 3 because 2, 4, and 6 there are 3 outcomes which are in favor of this question. Even numbers. Even numbers are 2, 4, and 6. So total number is 3. 3 upon total outcomes are 6. So 3 upon 6 is 1.2. This is the first one. Simple. Now second answer, let me write here. An odd number. How many odd numbers are there? 1, 3, 5, 3 again. Okay. So in the second case, number of favorable cases. Simple question. Favorable cases is equal to, let me write 1, 3, 5. Here odd numbers. So total number of this event and the number of favorable cases is equal to 3. These 3 are there. And total number of cases total number of cases is 6 equal to 6. Therefore, the probability of E in this case, second case, probability of odd, let me take odd number. Therefore, probability of odd number in this case is equal to 3 upon 6 again. 3 odd numbers are there. Favorable cases are 3 and total number of cases are 6. 3 upon 6 again, 1.2. So the two parts are completed. Simple. Now let me take other parts from here. The solution I am finding out. Let me take the third part here. In third part, number of favorable cases. Number of favorable cases is equal to, now third part say in number divisible by 2. This is divided by 2. Fourth part is in number divided by, this is third part, sorry, number divided by 2. This is third part, and fourth part is number divided by 3, this one. So third part is a number divisible by 2. This is by 2. So number of favorable cases, what are the number divided by 2? Even numbers, the same, 2, 4 and 6. So those cases are 2, 4 and 6. These numbers are divided by 2. Even numbers are divided by 2. So total number of cases, in this case, n number of evens. So number of evens NE is equal to, in this case, 3. Total number of cases again, total number of cases is 6. Total number of cases, let me take, total number of cases is 6. Therefore, probability of numbers divisible by 2 equal to 3 by 6 equal to 1.2. This is the answer. Now fourth part, a number divided by 3. Which are the number? Only two numbers are there, 3 and 6. We can find out this in that way also. Which are the numbers which are not divided by 3? Which numbers not divided by 3 are 1, 2, 4, 5. These 4 numbers are there which are not divided by 3. Okay, and divided by 3 are 2 only. So if I find that number not divided by 3 are 4, so 4 upon 6, 2 upon 3. 2 upon 3 is the probability of those numbers which are not divisible by 3. So what is the probability of divided by 3? Number of divided by 3? So it can be subtracted from 1. So total number of total probability, sum of all the probability is 1. Okay. So number divided by 3 and numbers not divided by 3, sum of these two events will be 1. So if I find in both the ways, we can find out the same answer. So 2 upon 3, the answer, this answer was 2 by 3. The numbers which are not divisible by 3, which are 4, 1, 2, 4 and 5. Okay, 3 and 6 are divided by 3. They are, suppose this is the other, two pages are there to solve this question, this part of the question. Any question can be solved in this way. We find out the opposite case, the opposite event, that suppose we have to find out that what is the probability of numbers which are not divided by 3. That we can calculate, and that subtract from 1. We can then calculate what the probability of the numbers which are divided by 3. So directly we can calculate that these are two numbers only. So in case fourth, numbers divided by 3. Which are those numbers? Number of favorable cases. Number of favorable cases. Let me take favorable cases, not number of favorable cases. In this case, favorable cases, not number of favorable cases, but number of only favorable cases are. Here favorable cases are this, not number. Number we calculate this 3. Now favorable cases in this case are 3 and 6 only. Directly we are calculating 2 only. The number of, or NE in this case, and E means event. Number of events in this case is 2, 3 and 6, 2. And total number of cases, total total number of cases is 6 always, is equal to 6, which is given to us. Therefore, probability of numbers divisible by 3. Numbers divisible by 3 is equal to 2 by 6, 1.3. This is 1.3. So 2 by 3 was the probability of those numbers which are not divisible by 3. If I subtract this 2 by 3 from 1, the answer is 1.3. This is 1.3 answer. So in both ways we can calculate this answer. Alright. That is the process of solving these kind of questions. So we find first we find the numerator, number of favorable cases. What are the number of favorable cases? That we can write then what is the number, what are the total favorable cases divided by total equal likely cases, total number of cases. In the denominator and numerator we have number of favorable cases. Now fifth part, a number less than 4. Less than 4. 4 is not included here. So what are those numbers? 1, 2 and 3. These 3 numbers are less than 4. Okay, so now favorable cases in this case, favorable cases in this case is equal to 1, 2 and 3. These 3 numbers are less than 4. Less than 4. Fifth one, less than 4. Okay, the dice will show the numbers which are less than 4. Only 3 numbers are there. 1, 2, 3. These 3 numbers are there. So their number is total number. So number of these events, NE means number of events is 3. 1, 2 and 3. 3 total numbers are there. And total, let me take T here. Total events or total number of cases is always 6. 1 to 6. That is always given there. Simple question. That's why, because this is not to be repeated. Therefore, probability of numbers less than 4 is equal to this 3 by 6, 1.2. This is the answer. 1.2 is the answer in this case, because there are 3 numbers only which are less than 4. 4 is not included, try to understand, it is not equal to 4, but less than 4. So only 3 numbers are there. Their number is 3, 3 upon 6, total number 6, that is probability 1.2. Now sixth part says, this is sixth part, a number less or equal to 4. Now less than 4 was 3, and now this 4 is also included, total number 4. In this case 4 upon 6, 2 upon 3. Now here favorable cases are is equal to 1, 2, 3 and 4. Simple. This question are taken so that one can understand that what is the process easily. Okay, that's why this question is easily taken up, right? Or we can just select these 4 cases are there which are in our favor of this event. In this event, or whatever the cases which are favorable to the event given. So these are the 4 cases. The number of these events is equal to 4. Total number of events is equal to 6. Therefore, probability of numbers less or equal to 4 is equal to 4 by 6. That means 2 by 3. We always write probability in the prime factor to each other. I mean least prime factor means the number should not be divisible. It should be in prime factors to each other. 4 by 6 was divisible by 2. So 2 by 3 is not further simplified. Okay. So simplest way answer must be the ratio is always in the simplest form. It is co-prime to each other. Numerator and denominator both are co-prime to each other. Prime numbers to each other. Okay. This is the answer. So sixth question, answer is 2 by 3. Sixth part, and fifth part was answer 1.2. These 2 are the answers. Let me take now 7th and 8th part. Question 5 has taken a lot of time because 8 parts of this question were there. We can say that there are 8 parts of this, means 8 questions are included here. Now 7th, the 7th part here. 7 says a number greater than 6, 0. So no greater than 6 number is there. How a number can appear greater than 6? There is no greater than 6 number, 0. In this case, so number of favorable cases, let me write here, favorable cases in this case equal to 0, as no number is greater than 6. Is no number is greater than 6. Why? Because only 1 to 6 numbers are there in dice. Numbering in dice is 1 to 6 only. No 7 number is there. So no number is greater than 6. So 0. 0 number of favorable cases. And total number of cases that we know about. Total number of cases. Total number of cases is equal to 6 that we know about. Therefore, probability of numbers greater than 6, probability greater than 6 is equal to 0 upon 6. That means 0. 0 upon something 0 instead of 7th answer. Okay, try to understand what are the favorable cases. That must be in the numerator. The denominator we are having total number of cases. Now 8th part, the last one. What is it? A number less or equal to 6. Now all numbers are less than 6, 1 to 5 and 6 equal to 6. So all the 6 numbers are included here. 6 upon 6 is 1. The number of favorable cases, in this case favorable cases, in this case favorable cases, in this case favorable cases are 1, 2, 3, 4, 5 and 6 because it's equal to 6 also. Right? Less than equal to 6. Less or equal to 6 means 6 is also included. Try to understand. And lesser values of 6. Less than 6. Less than 6 are 1 to 5 and 6 is also included. So all the 6 evens are there. And total, so this is the number of cases. Number of favorable cases. Favorable cases is equal to 6. And total number of cases is also total number of cases or equilateral cases is also 6. Therefore, probability of less or equal to 6, less or equal to 6, in this case is 6 upon 6 means 1. This probability is 1. Okay, so all the 8 parts of question number 5 are completed. This we have to just understand that what is the process. Number of favorable cases divided by total number of cases is the probability of the given event. Given events are these 8. When dice is thrown, that is the experiment, random experiment is done, outcomes are 1 to 6 and based on those outcomes, questions are given here, questions are asked here and those questions are answered. Okay, question number 5 completed finally. Let us take question number 6. Now what is question number 6 here? Let me first check it and then solve it. Okay, now question number 6, let us talk about question number 6 here. What is given to us? First let me read the question and then solve it. Okay, now question number 6 says that 2 coins are tossed. Okay, 2 coins are tossed together or 1 coin is tossed twice. In that way also we can say the 2 coins are tossed. What is the probability of the appearing of a part is at most 1 head, at most 2 heads. The 2 parts are there, A and B. At most 1 head, at most and at least. These 2 words are mostly used in case of probability. So let me talk about what is at most means. At most means minimum. I'm sorry, maximum. At most means maximum and at least means minimum. Now try to understand what is at most means. Suppose at most 2 heads. At most 2 heads means maximum 2 heads. It may be lesser than also. Means no head, 0 heads are there, 1 head is there, 2 heads are there. There are 3 cases total. three cases are included here. At most means maximum, and at least means minimum. This maximum more than that number which is given to us can also be possible. In this case, at most minimum is possible, and maximum number is 2, not beyond that. So at most means maximum, not beyond that, but up to that. Okay, so 1, 2 or 0, 1, 2, and 2 heads are there, only if you got twice, coin is tossed 2 times, so it means for 2 coins are tossed together, that means 2 heads may be there possible. So highest number of heads is 2, or highest number of tails is 2, and 1 head or 0 head, that can also be included in this at most. And the second part is at most 2 heads, and at most 1 head. First is at most 1 head. At most word is used here. Try to at most means maximum. Alright, so maximum heads we have taken here, and at most 1 head. So question number 6, let me write down here what is given to us. 2 coins are tossed. We are given here one event that 2 coins are tossed. Together is not needed. Okay, 2 coins are tossed. Only this is given to us. And what is to find out? To find out here. Now we have to find out. Our first case is A part. To find out A part. For the probability. First, let me write what is the probability of. What is the probability? Probability of the appearing of first part A is given at most 1 head. Try to understand. At most 1 head means maximum 1 head. It may be less than also. B part is at most word is used here. 2 heads. At most 2 heads. Now solution. Solution here. Now at most, as I have told you, at most means maximum equal to maximum, not more than that. We can say not more than that, but lesser can be, or not more than that, but less can be possible. Less can be possible. This is very important word used, at most. And at least 1. At least 1 means minimum 1. More than that also possible. Minimum 1, more than that also possible. So these at most and at least, these 2 words are mostly used. Please try to understand the meaning of them. Actual meaning is at most means maximum, this, not more than that, but lesser can be possible. And at least means minimum, but more than that also possible. So that I'll take if at least is given. At most is this part. Now let us take the question number, part number 1. So A part says we have to solve here at most 1 head. So what are the possibilities here? At most 1 head. That means how many possibilities are there? The number of, or let me take favorable cases are. In this case, favorable cases are first is no head. This is no head, 1 head, only 1 head. No head and 1 head, because at most 1 head and 1 head. This is 1 head. Only these 2 possibilities are there. No head and 1 head. Which are those possibilities? 2 coins are tossed together. So out of that, no head. Let me take what are the